In this tutorial, we're going to focus on learning how to graph two-dimensional linear inequalities. And we're going to start with something a little simpler. We're going to start with one-dimensional inequalities and work our way up towards the finale of this lesson. Besides just improving your education and your general ability to think about the world, what a lot of you don't understand, why should you learn this when in a few years after you're done with school or whatever reason it is that you're learning it now, you're never going to do it again. It's not practical and nobody sits around and draws these graphs. Well, what I think is the most important reason is an application called linear programming. This is something that people who breeze through their MBAs in school eventually go back to learn the mathematics because it's very helpful in business. It's a technique using linear inequalities to determine the best possible usage of your money, to optimize the usage of your money, to increase profits and decrease costs. And if you have any ambition about yourself in the future, whether it's to run your own business, manage someone else's business, or even just to do your own finances, I'm going to give you a very simple equation here. Not equation, but an inequality. Y is less than 2. All right? This is a statement that's saying that we have a variable y, and that variable can be anything as long as it satisfies the inequality that it's less than 2. Which means if I were to say y is equal to 3, that would be false because 3 is not less than 2. Same thing, I couldn't say 2 is not less than 2, 2 is equal to 2, so that's equally false. But I could say 1.9 is less than 2. I could say 1 is less than 2, 0 is less than 2, and -1 is less than 2. And I can go on and list every single number that's less than 2 towards infinity, which means I'll be here all day and you'll be here all day. But there is a more efficient way to do that, and that's just to say that y is less than 2, rather than discussing all of the possible cases. And that's really the purpose here, is to, we're coming up with a language that we can give these ideas instead of writing out essays on the matter. So we're going to start by graphing this. What are we going to graph it on? We're going to graph it on a line, a number line. The number line represents all the values of y. Instead of enumerating them, we're just going to draw this representation. So this represents y. We start with the origin, and in either direction we go towards infinity without actually writing all of the numbers. So 1, 2, 3, and it can go on to 4, 5, 6. And then in the other direction, -1, -2, -3. Now, what we start is we define our boundary. The boundary is the point where on one side everything is satisfying the equation, and on the other side everything does not satisfy the equation. In fact, nothing satisfies the equation. That point is 2. If you could tell by me listing these sample values here, at the value of 2, the inequality is not satisfied. Anything less than 2, it's satisfied. Anything greater than 2, it's not satisfied. And so 2 is the critical point right here. This is our boundary. Now, we typically draw either an open circle or a closed circle. Open circle or a closed circle. They represent two different things. The open circle represents when I have an inequality, when I'm using symbols like less than or greater than. And it means, when I say less than or greater than, it means that 2, the number that I'm putting the dot over, is not included in the values that satisfy the equation. Now, conversely, the closed dot here is used for less than or equal to, greater than or equal to, where the value under the dot does satisfy the inequality. All right? If I were to say y is less than or equal to 2, then 2 does satisfy the inequality. We would shade that in, and I'll show that in a second. But let's continue now with y is less than 2. So on the left side of 2, these are the values that satisfy the equation, the inequality, I should say. All right? -3, -2, -1, 0, all the decimals in between, and every number towards negative infinity. This is negative infinity is the direction here. and it just means that the numbers keep getting smaller and smaller in this direction. If they're getting smaller, then they continue to be less than 2. All right? And I was saying that I could also draw another number line. And the number line is the same because we're still talking about y, and I'm going to just continue to use the same numbers just because I like to. They don't have to be. I can go -4, I can go further, I don't have to go as far. Still, the boundary is going to be over 2 for y is less than or equal to 2. The boundary is still going to be at 2, but now it's going to be a closed circle because 2 satisfies the equation. 2 is equal to 2, so 2 is less than or equal to 2. All right, and it includes every number towards -infinity. I only drew the arrow up to 0 here, but see the arrow says it goes on forever. I just didn't want to intersect with my inequality here. Now, a common cause of confusion for a lot of people is what happens when it's flipped. This kind of thing confuses people. For example, I can say 2, I'm going to look at my original inequality. 2, what if I said 2 is greater than y? Now my variable is on the right side and my number is on the left side, but we didn't learn how to do it that way. We learned how to do it with the number on the left side, with the variable on the left side. So how do we do this? Well, you can graph it just as it is, but what I'd recommend is you flip it. You can actually flip it so it's in a form that you understand, and you could say y is less than 2. It happens to be actually the same exact inequality. 2 is greater than y is the same as y is less than 2. And we can show this with the rules of algebra. I'm going to give you a little aside here. This isn't really part of the lesson, but it's just something to help you understand a little bit better. If I had 2 is greater than y, I could use the rules of algebra to take the y and put it on the left side, the 2 and put it on the right side, so that's exactly the same as our original inequality. And I start by subtracting y from both sides. And I have 2 minus y is greater than 0. There's nothing left on the right side. And then I bring my 2 over. I subtract 2 from both sides. And I have negative y is greater than -2. But our original inequality didn't have negatives, it was positive, so we have to multiply both sides by -1. But there's a rule in algebra that when you multiply both sides by -1 to get positives, you have to flip the sign. So we would get y is less than 2. And that matches here. So I could take 2 is greater than y and flip it, and it's y is less than 2. Basically, you just take the left side, put it on the right, and remember to flip your inequality sign here. All right? So if you wanted to graph 2 is greater than y, you graph it in the same exact way as y is less than 2. That's the easy way. All right? Now, moving on, we're going to go to two-dimensional inequalities. There's not much more we can do with one-dimensional. But what I'm going to do is, I'm going to draw the inequality, I'm going to graph it on a two-dimensional Cartesian plane, but I'm going to draw it's really a one-dimensional inequality still, because I'm going to draw the same exact inequality that we drew on the one-dimensional line. I'm going to draw y is less than 2 on a two-dimensional graph, which is superfluous. It's extra work. It's more work than we need to illustrate the point, but it's going to let you see the comparison between the two methods, the two graphing in one dimension and graphing in 2 dimensions. And bam, there's my graph, which I just took a few moments to draw out. You could see this is the y-axis. Remember, we were just using a one-dimensional y-axis, and here's the x-axis now. We've added an additional variable. But our inequality is still the same. It's still y is less than 2. How do we graph that two-dimensionally? Well, here we were using a dot to represent the boundary. We're still going to have a boundary here, but because we've increased the number of dimensions from 1, just y, to 2, x and y, instead of using a dot now, we're going to use a line. We've increased the dimensionality of our boundary. So we're going to draw y is equal to 2 as our boundary, okay? So here's 2, here's 1, here's the origin, and we draw a dotted line. A dotted line is the equivalent of the open circle. And if the 2 was included, like in this example, we would actually draw a solid line. Everything under the line here, I'm going to shade in. And the reason is, this shading is equivalent, it's the 2D equivalent of drawing this arrow. I'm saying that everything in the negative direction, see this is negative y in this direction, I have -1, -2, -3, on down towards negative infinity. Everything in the negative direction is going to be satisfying this equation. And let's pick a point. A typical way to figure out what side to shade on, here I just told you, but if you want to figure out what side to shade on, you pick a point. Let's pick 0, 0. That's one of the easier points because 0 cancels things out. So this is our boundary here, y equals 2. And this graph is for the equality y is less than 2. If y is 0, then we have 0 is less than 2. It doesn't matter that x is 0 because there's no x in our inequality. 0 is less than 2, that's true. We can pick another point. We can pick -1, 3. This is 3, -1. X is 3, y is -1. So x does no place in our inequality, but y is -1. -1 is less than 2. This is also true, all right? So everything on this side that we've tested is going to satisfy the inequality. And x really doesn't matter because the inequality is a function of y. So this graph represents exactly the same information that this graph does. It's just using 2 dimensions. Now there's no reason to use 2 dimensions in this case because we're not showing any additional information. But now we're going to go over a case where we do show additional information. I'm going to give you a 2-dimensional boundary so that we actually need a 2-dimensional graph. Now we're going to use a different inequality. It's still going to be something simple, but I'm going to have to add an additional parameter. We're going to say y is less than or equal to 3x. Now you should have learned this in some additional part of your life, some additional tutorial, how to graph y is equal to 3x, which is going to be our boundary. All right. We take our starting point here, our y-intercept is going to be 0 because we're not adding any constant to the end of this. So you see this is in slope-intercept form. Slope-intercept form is y equals mx plus b. B is our constant, and in this case b is 0. All right, and that's where it's going to intersect on the curve, on the y-axis. And we're going to have a slope of 3. So here's our y equals 3, x equals 1. Whoop, I just missed the point there. Y equals -3, x equals -1. And the line goes on towards infinity in both directions. All right, now we're going to pick a test point. Let's pick this side because I know the future. And this point is x is 3, y is 0. We're going to plug the values at this point into our inequality. So y is 3. Y is 0 is less than or equal to 3 times x is 3 plus 0. 0 is less than or equal to 9. This is true. Because this is true, everything on this side must be true. And you can go and test them yourself. There's no reason to test all of the cases because there are an infinite number of cases. All right, so we shade this side. Every value that falls under this shaded area, and the shaded area goes on to infinity, satisfies this inequality, y is less than or equal to 3x. All right, now you also, I want to point out here is that I drew this as a solid line. Okay, it's a solid line because it includes the boundary. The boundary here is y equals 3x, and that satisfies that will satisfy also. So here 0, 0 is on the boundary. If I put 0, 0 into this inequality, I get 0 is less than or equal to 0, which is true. So that everything on the boundary also satisfies the inequality. And that's really all there is to graphing linear inequalities. So I hope that if there's any questions or comments, or if you found any errors in the presentation, that you'll leave comments.